Hello, alright, good morning, alright, good afternoon, or good evening, right, whichever it is at the moment. Right? I'm gonna try to explain exactly just how this assignment's gonna be working out. It's our practicing limiting reactants part 2. Right, we have this example right here. We have our following reaction, and it's already balanced. It says that you need 1 mole of nitrogen plus 3 moles of hydrogen to get 2 moles of ammonium. Now here in our assignment, we're basically figuring out which one of these is our limiting reactant. Right? Given a scenario where you're given a certain amount of each component or each chemical, right? Let's say we were just given 100 moles of nitrogen and 100 moles of hydrogen. And when we do our calculations to figure out, well, how many moles of ammonium would be possible to make, we're assuming that you had enough of everything else that was needed. So if this was like a recipe, per se, right, that's what these molar ratios are talking about. For every 1 mole of nitrogen, you get 2 moles of ammonium. Right? So you could kind of think of this like you need 1 cup of sugar and 3 eggs to make 2 batches of brownies, right? 1 cup, right? 3 eggs, 2 batches, right? That's the ratio. For every 1 cup of flour, you get 2 batches of brownies, right? We're going to use this idea of this ratio, right? Except we're going to apply it to our chemistry this time. So assuming we had 100 moles of our nitrogen gas right here, we're going to multiply it by our mole ratio. And that's what this guy is basically right here. Remember, since we're going from nitrogen, right, and trying to figure out exactly how many moles of ammonium we can make, right, we've got to make sure that we do the numbers correctly. Since we're dealing with nitrogen, that's where we get our 1, and we're trying to convert it into ammonium, that's where we get our number 2. So as we're trying to convert it from nitrogen into ammonium, so we got to make sure that we know it's a 1:2 ratio for ammonium from nitrogen. So we take our given amount, right? We divide it by what we know we're given, which is nitrogen, and then we multiply it by what we're trying to get it into, which is ammonium. So 100 divided by 1 times 2 ends up being 200 moles. That's how many possible moles of ammonium we could make. Here we have 100 moles of hydrogen gas. So again, behind the scenes, we got to take our given amount, divide by what we're given, which is hydrogen in this instance, and we're multiplying it again by what we're trying to get it or convert it into, which is ammonium. So 100 divided by 3 times 2 gives us 66 moles of ammonium. That's possible. So notice that there are these little asterisks, right? That's telling me that, oh, I know that this is the one that is limiting because it runs out first. If you're asking yourself, what do you mean when it runs out first? Well, because we both assumed that we had 100 moles of each, right? We're trying to figure out which one's limiting us, right? Let's say we're just making it like usual. I made the 64th mole, 65th, 66. We try to make that 67th mole. Well, we've run out of hydrogen by then, right? Even though we have plenty of nitrogen left, hydrogen ran out. So it's the smallest number possible. That's the one that is our limiting reactant. So that's how you know, like, okay, I need to stock up right? And you do some budgeting, right? What do I need left, right? So here, right, this is what the rest of the assignment looks like. I'll go perhaps over part A just to make sure you guys might understand it a little bit better once you see it kind of happen in action. So here, we're given 60 moles of aluminum, and we have 150 moles of our oxygen. Now I gotta figure out the math part. Remember, it's our given amount, which in this case is 60. Right? We have to divide it by what we're given, which in this case is aluminum, so the number in front of aluminum is 4. I multiply it by what I'm trying to convert it into. In this case, it is our product, aluminum oxide. If I do that math, right, 60 divided by 4, which is 15, times 2, ends up being 30 moles possible of our aluminum oxide. Right, now we do the same thing with our oxygen. Right, but this time our given amount isn't 60, it's 150 moles of oxygen. Remember, we got to divide it by what we're trying to have. Right, sorry, what is given, which is our oxygen. So that's going to be a 3. If you're asking, where do I get this number? That's this guy right here, oxygen, right, is 3. And then I multiply it again by 2, because that's what we're trying to get it into. We're trying to convert it into our aluminum oxide, our product, because we want to know how much we could technically make. So this is where that 2 comes in, right here. That's what we're trying to convert it into. So if we do that, 150 divided by 3 is 50, times 2 gives us to be 100 moles. So now I know, okay, remember the smaller number, right, that is our limiting factor, right, because it's going to run out first before we run out of our oxygen. So I want to put little stars by it, so I know, oh, okay, this guy, our aluminum, is going to run out really quick. Alright, maybe I should stock up on that, go back to inventory, check up on that. Alright, put it in order, so I make sure that everything goes smoothly. Alright, so hopefully you guys don't have too much difficulty figuring this out. Again, if you have any questions or concerns, do email me, and hopefully get back to you guys as soon as I can. So, stay safe out there. To see you guys soon. Alright, later.